Hi, this is Abhijit from Beyond Vectors, and today we'll learn some basics about LangChain, right? Um, LangChain, before we kind of understand a lot about LangChain, let's understand some core programming concepts. There are a lot of terms which are thrown out, and it's better for us to understand each of these concepts clearly. So, what is LangChain? LangChain is a framework, right? And what is a framework? It's a structured foundation that provides basically some tools and rules to build application. Like LangChain is a framework, Google ADK is a framework, and then Ruby on Rails is a framework, so on and so forth. Right? That's a definition of a framework. And LangChain is specifically a framework for building LLM-based applications. Right? Now, a framework will have a lot of packages, right? What's a package? A package is a collection of modules which are grouped together, and we'll come to what modules are later, but they're grouped together to organize some functionality. Now in LangChain, for example, LangChain underscore core.prompt, which you see here, is a package and it contains all the prompt related modules. Okay. Now, next concept which we need to talk about is what is a module? Now, a module is a single Python file, and within that Python file, you have some reusable pieces of code. It contains related classes, functions, and variables, right? In LangChain, chat.py could be a specific module. Now, what is a class? A class is basically a blueprint which can be reused in many pieces of code. It is an object-oriented programming concept. So, for example, think in a retail concept, in a retail setting, a product is a class, right? It's a blueprint for many types of products like a laptop, a phone. All of these are objects which are an instance of a class product. Okay. So, a class is a blueprint for creating objects, and classes have two things, right? It has a group of things to define the class, and they're called attributes. And it has some behaviors which that class can do, which is the methods. So in the LangChain, chat prompt template is a class, right? And it is used to create structured chat prompts. Now, object, on the other hand, is a specific instance of the class. Going back to our retail example, if product was a class, then a specific product like laptop was an object, right? So in LangChain example, if you think about it, what is an object? So think about the definition here, right? Prompt is equal to chat prompt template from messages with some parameters given inside, right? So this prompt is a specific object of class chat prompt template. Okay. And a, a class has attributes as well as methods. So all these attributes and methods become available for the object of that type class, right? So a method is basically a function which is defined inside a class, right? So let's go back to our example. What can a laptop do? A laptop can be used for coding. So similarly in LangChain, I can invoke a class, an object called LLM and make it say hello or pass hello to it. Okay. So now that is a method, right? And the last concept I want to talk about is an attribute. For example, an LLM object will have temperature as an attribute. Attribute is basically a bundle of data or a specific data which is kind of um, giving a particular personality to the object, if you will. Okay. So with these concepts clear and out of our way, now let's go to understanding the basics of this framework called LangChain. And we'll do that basically by looking at building some specific pieces of code. And we'll build that code using Llama model, which is a model from Meta. And this Llama model exists in an inference service called Grok. Okay. And the core concepts which we will understand today is how LangChain treats LLMs almost like a function, right? And we'll understand the idea of prompt templates, which is like reusable, parameterizable prompts. We'll understand LangChain expression language LCEL and how we can chain different components using this operator called pipe operator. Okay. So there is this pipe operator, which is kind of the most interesting part of LangChain. We'll understand how LangChain helps us parse output of LLMs. And we'll also understand how memory is managed, especially the short-term memory is managed by LangChain. If you're new to this, entire world of building agentic AI or LLM-based applications, you always need to define a model, and you need to connect to this model via an API key, right? So the prerequisite to run this notebook is that you go to console.grok.com, create an API key for yourselves, and store it in some safe place, because we'll use that later in our code. Okay. So the first thing which I need to do is I'll need to install some packages. All right. So I'll install these packages like LangChain-Grok, LangChain-Community, even LangChain itself is a package here. So each of these packages, I install them first. So it'll take a few seconds for this installation to complete. Now, once this installation is complete, now I want to basically pass the API key, which is used for me to connect to this Grok server. Okay. So for that, I have this os.environ with Grok API key, and I pass that API key right now. So in this box, I can quickly go and paste the API key. I've already done the creation of API key and all that. So if I hit enter, the API key is set. These are basics. Now let's look at the fun part, which is using LangChain. Okay. So let's kind of look at what is happening in this cell. So I have from LangChain Grok. LangChain Grok is a package which I had installed earlier. Import a class chat grok. Okay. So this is a class of chat grok. This is what I did. Okay. Now what I'm going to do, I'm going to create an object called LLM. And this object is of the type chat grok. And I'm going to pass two attributes to it. One is a model attribute and the other is a temperature attribute. And the model attribute, I pass the specific model Llama 3.370B versatile. And I set the temperature of the model to be 0.7. Okay. Now what do I want to do? I want to see if I can run this object, right? So if I have to run this object, what do? I do llm.invoke and I pass a string. Okay, I pass a string to this. And so this LLM object, it returns another object of the type AI message. Okay, so we'll just confirm that is true. Okay, so when I let me comment this out and run. And see what happens. Okay, notice it has created a class from LangChain core.messages.ai.ai message. So it has created an output response, which is it's an object of the type AI message. Okay. So now this AI message object has the contents of the response. It also has some metadata, right? So I can remove this and see response.content, right? And let's see what the response.content is. Okay, so this is the response of this LLM, right? If you see, here is the fun facts about Python program, and the LLM has kind of responded. I can also look at, say, response underscore metadata, okay, and see what metadata comes out, right? I get some metadata like token usage, prompt tokens, total tokens, time for completion, and so on and so forth. So this object has these attribute response.metadata and response.content, right? You can also pass some structured messages using system message and human message and to this object LLM and invoke it. For example, here I've squished system message as well as human message. Both of these are classes, right, of from LangChain core.messages. I've imported these classes, and with this, I've instantiated the specific messages, and I've kind of passed a list of messages. And I'm going to get the response and print the response, right? So here I'm saying you're a helpful assistant that speaks like a pirate. Tell me about machine learning, say in 3 bullet points, right? And I hit enter. Notice it says ye wanting to know about machine learning, and it talks like pirate and gives you in 3 bullet points, right? So what are the key things which we learned? We understood this chat grok class. We understood how to create an object of that chat grok class. We understood it has method called model. Sorry, it has an attribute called model. It has an attribute called temperature. And it has dot invoke, which is a standard way to call LangChain component. We understood about AI message, which is an object, which is the output of chat grok. And to print the actual content of that object, you need to do AI message.content. And that's all you learned right now. Moving on, let's understand about prompt templates. Look, if you're building LLM applications, you need to prompt the LLMs. And it's often a good practice to create a template of reusable prompts, right? So, and LangChain makes it easy for you to create such templates. So you can basically import chat prompt template, which is a class, which will help you kind of create a templatized prompt. Okay. So let's see what is happening here, right? So I've defined a prompt, which is an object of class chat prompt template, and with from messages, which is a method, and I'm passing to that two things. I'm passing a system, a tuple of system and a string, and a human and a string, right? And what is in the system? You are an expert in curly braces, there is topic, and then explain the concepts concisely. And I have human with in curly braces question. So these, whatever is inside this topic and question, inside these curly braces, the topic and question are basically placeholders, which we can fill dynamically later. Okay, so let's just print what are the input variables in this object called prompt first. Notice question and topic are the two input variables. Now we need to fill these variables with something concrete in a prompt, right? So I'll fill topic with astronomy, question with why do stars twinkle, right? And then I'm going to see if I can print this. So it says system this variable is you are an expert in astronomy. So it is change the topic to astronomy. Explain the concepts clearly and concisely. And then the human says, why do stars twinkle? Now we are going to send both of this to the LLM, and then we're going to invoke that LLM, right? So here, if you see, response is equal to LLM dot invoke with this specific variable. Let's print, and you notice that the LLM has responded. Okay. Now I could reuse the same template for a very different topic, right? Here I use the topic of astronomy, and the question was, how do stars twinkle? I could use it for a different topic like cooking and say, what's Millard's reaction, right? Let's run this. And I don't know, it responded with what Millard's reaction is. Maybe with cooking, and ask, let me see if LLM knows this. What is tadka? Okay. So this is an Indian way of kind of tempering food, and I have what is tadka here. Okay. All right. So now what we've learned about this class called chat prompt template, and we understood that we can create placeholders with variable names, and you can invoke it with the dictionary of the variables, and this makes the template reusable. Now let's look at the next concept, which is the concept of chaining, right? And this is the core of LangChain. So what you can do is you can actually chain multiple components, right? So prompt is an object, and LLM is an object, and output parser is an object. Each of these are LangChain objects, and you can basically pipe them. This is like the Unix pipes, where you can it's a syntax of LangChain, where you can send the prompt and pipe it to the LLM, and then LLM's output can be piped to the output parser. This makes the code very readable. It makes the code development organized, right? So if you see here, what I've done from LangChain core output parsers, I'm importing a class called string output parser, which is required further. And I'm going to create a chain. The chain has the prompt from which is defined above. It has the LLM which is defined above. And then I'm chaining both of these, and then chaining the output of LLM to the string output parser. Right now, I can invoke the chain, and this will basically sequentially invoke all of these. Right. So if I see this chain invoke, and I pass a topic history and what caused the fall of Roman Empire. So this is the prompt which will go to the LLM, and then the output is passed as a string. But before that, let us quickly understand if it is actually giving the output as a string, right? So if I see here print type result, which means I'm asking what is the type of this answer called result, right? And so let's first see that. Okay, so this is of a class string. So at least we know that the string output parser has done its job. It has parsed through and it's given an output of class string. Now, next, what I'm going to do is I'm going to actually print the results, right? Notice it has given the full results. So here, this is basically chaining of multiple components. And chaining is an important concept, right? You can chain to get the full answer. You can also chain to stream the output here. See, if you see here, I did for chunk in chains.stream, which is an inbuilt um, method in LangChain. So I'm going to print for topic physics, explain quantum entanglement in simple terms, and I'm going to print each chunk. Okay. So let's see. Notice that if it actually printed in a streaming fashion, it didn't give the full answer in one shot. So this is again useful, right? Especially if you're building a chatbot or an LLM application and you want to stream the output. You can also do batch processing. For example, here I have a list of 3 questions which are put in a JSON object. So there are three dictionaries, right? Topic one, which is biology, and the question is what is CRISPR. Topic two is mathematics, and the question is what is Fibonacci sequence. Topic three is music, and the question is what is pentatonic scale, right? And basically, I can get the results for this entire chain using chain.batch with questions, right? So it batch processes the results. So I can run that and notice that it has given the results for biology, math, and music, right? Again, different things become easier just because you are using a LangChain as a framework. Now, moving further, you can also chain multiple steps together, right? So here I have a topic prompt, which takes a topic, and uh, this topic prompt, and also have a poem prompt, which says write a 4-line poem about the topic, right? Now, I'm going to first create a chain where the topic prompt is sent to the LLM, and the output of that LLM is passed as a string using a string output parser, right? And next, I'm going to create a full chain where this string is passed to the poem prompt, and the poem prompt passes this to the LLM, and then the output is sent as a string output parser. And the result is something which I'm going to look at, right? I'm going to do a full chain dot invoke, and I'm going to give a category science, which is the topic. So I need now take this topic, right? Give me a one interesting, science topic in 5 words or less. Just the topic, nothing else is the first prompt. So the chain one is going to basically create that prompt, that output, and that output is fed to the poem prompt, and you're going to get a 4-line poem about science. Hopefully, let us see if that's true. Notice the cosmic darkness, a void is found, the black hole's gravity wraps all around, and so on and so forth. So it created a 4-line poem on science, basically by chaining the chain 1 and chain 2. All right. All right. So what are the key takeaways here? We understood about this pipe operator, which is used to pipe components together. And we understood some ideas about LangChain expression language, that is .invoke, .stream, .batch. And we understood about string output parser, which extracts strings from AI message and sends the output, right? So basically, you also understood that you can nest chains, right? And typically, if you're building complex applications using LangChain, you want to know how to do this really well. The next concept I want to talk about is how to parse the output, right? An LLM application doesn't stay in isolation, right? In enterprise, you have LLM applications which are then written, which write to the downstream software applications. So it's very important for LLM applications to give output in specific formats, maybe as a string, as a JSON, or with a specific type which is validated, or as a CSV, right? So all of these are output formats in which downstream applications may want the LLM applications to give output. But LLMs themselves just give this AI message, right? So we will now look at different output parsers which are there in LangChain, and we'll understand them, right? So the first output parser we are going to look at is a comma separated output parser. So this parser, you can kind of look at get format instructions as a method, and it will tell you what the instructions of this parser is. So if I print it, it says the format instructions is your response should be a list of comma separated values, which is like this, right? So now we'll see how this how this can be kind of used in a LangChain, right? So if you see here the list chain, it takes a prompt, right, which is the human list 5 categories, and it passes it to the LLM. The LLM may give these 5 categories as a big text, and then the list parser takes that text and converts it into a comma separated value, right? So let's run this. Look, the class is list, and it created a list of Python, Java, JavaScript, C++, C hash. And the first item is Python. So you kind of look at results with square bracket 0. So the first item here is Python. Similarly, we can look at a pedantic output parser. Now, pedantic is very useful for doing type checking, which means you want to make sure that the specific type of output is given, and very useful. So same way, I'm going to create, a class called movie recommendations, and it should have basically a title, which is of type string, a year of type int, genre, which is of type string, and reason, which is of type string, right? So now this specific class, movie recommendation, I want to kind of look at this specific structure in the output, right? Or I want to create an output of this structure. So I create a pedantic parser, which is basically using this pedantic output parser class. So this pedantic parser here is an object. And I'm going to look at format instructions of this pedantic parser, right? So let us see. So here it gave, as an object, it needs to kind of give this title with description. It gave all these details, right? So this is the get format instructions for the pedantic parser. Now I can give a specific movie prompt and chain this to LLM, just like the earlier case, right? And make sure that the output follows this pedantic parser. So let's see, right? It clearly created an output of class title, inception, year 2010, genre sci-fi, why it's a complex, mind-blowing movie, and all that details. So similarly, I can create a JSON parser, right? So if you see here, I have a JSON parser object, which is created using a JSON output parser class. And I have a JSON prompt, and I'm going to chain the JSON prompt to the LLM and to the JSON parser. And I'm going to invoke this chain with dish as chocolate chip cookies and the format instructions, right? Notice it has created a nice JSON object with the recipe, which is a Python dictionary, right? So it's created a dictionary, and basically this is a JSON object, right? So JSON.dumps basically convert it into a Python object. But so this is what you see. Nice. So the key takeaways in this section is, we understood how output parsers can turn this free-form LLM out text into Python objects, which can be then used in downstream functions, right? And we understood about this get format instructions method, which is useful to understand the instructions which is you kind of pass to the prompt, right? And then pedantic output parser gives you type safe validated objects. And JSON output parser is basically a lighter weight version of this, which you can use without much validations. But it's very useful in kind of sending data to APIs and so on, right? And parsers can be plugged in LCEL chains, right? So this is something which is also we observed that. The next or the last concept is this concept of how to manage the conversation buffer memory, right? So we know that LLMs don't have memory, they're stateless, right? But if you think about chatting and things like that, there needs to be a memory which needs to be maintained. And this is the memory which is maintained in the buffer, right? This is the simplest type of memory. So every time an AI sends a message or when a human sends a message, you kind of put that in that buffer and bring it into the into the context every time you run the LLM application, right? So here, let's kind of understand the approach which is used, right? I'm going to import in-memory chat message history. Okay, this is a class. Chat prompt template and message placeholders are basically ways to manage prompts. The output is a string output parser. And I have this from LangChain core runnables.history. I have runnables with message history, which is a class. Okay. Now I'm going to create a dictionary, empty dictionary, which called store. Okay. Which I will start filling as the chat goes on, right? And I'm going to define a function called get session history, which is going to take a session ID and it's going to give a in-memory chat message history as the output, right? So if session ID is not there in store, then store session ID is passed with the memory, right? So this is a function. Now I'm going to create a memory prompt with chat prompt template, and the system says you're a friendly assistant, be concise, and the message placeholder is a variable name with human and input. Okay. Now I'm going to create a base chain with memory prompt sent to the LLM and then with a string output parser. And I'm going to wrap this entire messages with runnable with message history, right? So this basically takes the base chain and it takes the get session history, which is a specific method, and then input messages key and the history messages, which is a history key. Okay. And let's see, we'll run this function first. Okay. Chat with memory is ready. So runnable with message history will basically create that. Now let's look at the first turn in the conversation, right? So I create a config, which is configurable with session ID as user123. And I'm going to get the response one, which is chain with memory dot invoke. So let's see what is chain with memory here. Chain with memory is this specific object of class runnable with message history. It takes this base chain, runs it, gets session history, and input message key is input and the output message key is history, right? So let's run this first one and print the response. So the input from the human is, hi, my name is Alex and I'm learning Python. And the bot responds, right? And the response one is what I'm printing. And if I print this response one, it says, hi, Alex, welcome to Python. What do you need help with? Right? Notice I've just typing response one because the output is of type string already. Why? Why is it output of type string? Because I'm using a string output parser here. Okay, got it. Now let's take a second conversation turn with the same object, right? So response 2 is chain with memory dot invoke, right? And what is my name and what am I learning? So I'm just asking if that memory is still there. So I'm going to check that with this print statement, right? Notice your name is Alex and you're learning Python. So the bot basically understood based on whatever was the history. Now let's look at conversation turn 3, right? Here, can you suggest some good first project for me? So now it should again remember that it's Alex and he's learning Python and it has to suggest a project in Python, right? So when I do chain with memory.invoke, a good first project for Python beginner is a to-do list app or a simple calculator. Okay, good. Now I can inspect this history, right, using this get session history method for user123, right? So let's inspect this history. Notice that there are 6 messages. First, the human said, hi, my name is Alex. Then AI said, hi, Alex, welcome to Python. And then human said, what's my name? And it remembered the name. can you suggest a good first project? And then it gave the answer. So this is the dump of the memory which was in the buffer. Now I can basically look at another session. So here with the config new, I have configurable with session ID user 456, right? And I'm passed this new configuration to the response, right? Chain with memory dot invoke, and I'm going to print the response, right? And I'm asking in the prompt, what is my name? Because it is for user 456 and there is no, name given here, I should not get Alex here, right? Because it's a different session. So let's see. The bot says, I don't know your name. I'm a text-based assistant. So you can basically manage text, sessions using this config parameter. Okay. So what all did we learn here? We understood that LLMs are stateless by default. We understood runnable with message history, wraps a chain with the conversation memory. We understood message placeholder, which will have all the past messages. We understood the idea of this session ID where you can isolate the memory, right? It's great for all these multi-user apps. We understood about the buffer, which stores everything and puts it into the model context. So I think we understood quite a lot together. Now, finally, I want to put all of it together. So we're going to build a small LLM application, which is going to be a mini app which combines everything and gives a structured recipe. All right. So I'm going to import chat prompt template, message placeholder, JSON output parser, runnable with message history, and then in-memory chat message history, and then chat grok. So these are things which I'm going to import. And I'm going to define an object of class chat grok called LLM, right? And then I'm going to give a prompt called chef prompt, which is of, it's an object of class chat prompt template. And then I'm going to create a chef store, which is a session store, right? And define a function called get chef history. So each chef can basically ask a different dish, but his history should be maintained separate, right? And I'm going to chain this, right? So I'm going to have a chef chain, which is the chef prompt is passed to the LLM, and then the output is passed to the JSON parser. And to make sure that it's like a chat with conversation history, I'm going to wrap it with runnable with message history, right? So in that runnable with message history, I'm going to pass chef chain, get chef chain history, input messages key, and the history message key, right? And specifically, now I'm going to create a config for the chef session and say, ask for a recipe, right? So the recipe is give me a quick pasta recipe, and I'm going to pass this config. So let's run this and print what output we get. Notice it gave the pasta recipe here. All right. Now, if I ask a follow-up question, right, which says, can you make that recipe vegetarian, and pass the same config, which means it's the same user who's asking it, then it should probably give me some ideas to make that pasta vegetarian, right? So it says to make the recipe vegetarian, you can place meat based on ingredients replace with plant-based alternatives such as tofu and so on and so forth. Okay. So just to summarize what all we learned, the idea of what LangChain is. We understood that LLMs can be treated as functions. And then we understood the idea of prompt templates, and then how to chain different components using pipe operators. We understood output parsers and memory, right? And we put it all together to basically create a small app. All right. I hope you understood this and found it useful. Thank you. Bye.